Here we are tasked with finding the value for this trigonometric integral. We are also given a hint, and that is that we should probably take the derivative of sec squared. Well, I don't want to say that it is a well-known fact, but it is a fact that the derivative of sec of x is sec of x times tan of x. So maybe the derivative of sec squared of x is sec squared of x tan of x, right? That would be very cool, because then we found the antiderivative. So let's take a look at it. So the derivative of sec squared of x is, first off, sec squared of x is equal to 1 over cosine squared of x. This is just by definition. Then I would like to apply the quotient rule here. So I get cosine squared of x all squared times cosine squared of x multiplied by the derivative of 1 plus, minus 1 times the derivative of cosine squared of x. So clearly the derivative of 1 is equal to 0. So this is all equal to 0. Then I have something that looks like this. So what's the derivative of cosine squared of x? You bring the power down, and then you write cosine of x, and then you take the derivative of the inside function. And the inside function in this case is the cosine. The outside function is x squared. That's why I wrote 2 cosine of x. Now the derivative of cosine of x is sine of x. No, it's the negative of sine of x. Yeah. Now I have 2 minuses here. 2 minuses make a plus, but 2 wrongs do not do a right. So that's that. Cosine squared squared is just cosine to the 4th. And here on top I have cosine, so this would be a power of 3, and then a sine of x. But then I can just write this as sine of x over cosine of x times 1 over cosine squared of x. Because cosine of x times cosine squared of x is cosine cubed of x, and that's why it works. But then notice that this is the precise definition of the tangent function. And that is the definition of the sec function. But let me not forget, please do not let me forget the 2 that is here. So, if the derivative of sec squared of x is equal to now I'll just write those immediately. So I'll write 2 tan x sec of x Then what can we do about this? Take a moment to think about this. Here's what we can do. So if this is true, that's where the mistake is. So here's what was happening. I was looking at this, and it wasn't making any sense to me. 1 over cosine squared is sec squared. Now it makes sense to me. Because this should look like that. And now it does. If it didn't, then it would be a problem, because I would have to redo this video once again. But I'm just kidding. So I just forgot to write squared. I mean, 1 over cosine squared is sec squared. 1 over cosine is sec. So that's a piece of info for you. Then tan of x times sec squared of x is the half of this derivative. And that is a completely and totally legitimate statement which I can write with full confidence. Not like the other statement which I was a bit hesitant to write. Then I hope you don't mind if I do like this. I will replace tan of x sec squared of x with this. And I don't want to say this, but I'm sorry. You cancel out and you get half sec squared of x plus c. Now they don't actually cancel out. There's something called the fundamental theorem of calculus, which tells you that the derivative of the integral is equal to the integral of the derivative, which is equal to the function. So that's what it says. And that's the answer for the question.